All right, well, thanks everybody for coming. I get 2 tries at this. You guys are the guinea pigs for the first one, and then I'm doing this talk and the UAV one again tomorrow. Just maybe a quick show of hands, because I'm just curious, how many people here actually work with disaster data? Okay. And how many of you leave your hands up if you're using FME to do that? Okay, cool. So definitely I want to leave some time for questions at the end, because I also want to learn from you guys as well. So hopefully this is more of a conversation than might be possible if we were doing, let's say, a webinar. So the purpose of this talk is I'm not really an expert in disaster response. It was more of to do a survey of what's out there, how are people using FME for disaster response. There's a few areas where I have some personal experience that I've brought into it, and then a lot of other customer examples. And we're going to start off by what are some of the unique challenges in relation to disasters that we're faced with when we're dealing with information management, and then how does FME address those challenges. Overall, a look at maybe a better title might have been disaster management, because we're not just talking about the response, but also planning and mitigation and restoration afterwards. So there's that whole disaster management cycle and different approaches to data integration and lots of examples. So what I'll try to make sure, I'll have to double check when we get the PowerPoint published to make sure that some of the links actually all work, so that any of these examples that you're curious about, hopefully you can follow up and get more information on. So what are some of the challenges unique to disaster response? Like a lot of other areas, let's say dealing with environmental data and elsewhere, we're dealing with a huge range of data sets. But the unique thing about disaster response is that the timelines are highly compressed. So it's a very stressed environment. You got to get on the ground, and then basically every minute, every hour matters. When a disaster happens, often, let's say, for example, I think there was somebody reminded me at this conference that in one of the tsunamis, I think in the Solomon Islands, initially there was really no sense of what the casualty rates were. Villages just stopped communicating, but they basically were wiped off the map, but people didn't know, did the villagers get away? Are they in the hills? So just getting an initial assessment of what the extent of the problem is, that's a huge challenge. And then you have a whole range of data types to work with. So it's not a nice, predictable environment where you can say, well, I'm going to work only in Esri, or only in Autodesk, or only in Open Standards. So you're going to have this whole mishmash, fairly chaotic environment to work with. Then there are limitations in the infrastructure. So we might love API. You have your favorite APIs and favorite web services, but if you have no internet, good luck. Or as is my experience, my brother works with satellite internet communications, and download's pretty good, but upload can be painfully slow. And so if you're dealing with latency like that, that can be a challenge. And then on the ground, you have very limited resources, not just technically, but also in terms of the hardware or software, but also in terms of the human resources, the expertise available. So you may have a fairly complex system which works fine here in Vancouver because you've got the know-how to deal with it, but on the ground in the field where one guy is wearing 10 hats, he doesn't have time to decode your complex solution. So lots of urgency, we need results yesterday, and then so how can we optimize some of our workflows to deal with that? So here's some ideas about some of the opportunities of how people have addressed this. Coming up with some common data models ahead of time, and we'll look at a few of those. For example, Inspire was one that was thought of in conjunction with this. Open standards in general, say from the OGC. Making things cloud-based, because I don't know if I have a specific example, but from New Orleans' example, their entire GIS infrastructure was essentially flooded out. All those servers went down. So if they had things that were more cloud-based and then had an off-site solution, that would have helped. Mobile devices, crowdsourcing, other web sources, real-time feeds, and ultimately having an approach, I think, that's model-based, where you can have a rapid prototyping environment. Obviously, I'm going to have a bias for using FME to do that. But having something model-based and data-focused rather than tons of codes or scripts that might be opaque to new users. So yeah, I believe FME is one example of ultimate data integration tool. I won't spend too much time on this. I'm just trying to summarize some of the high-level points. I think FME is a good bridge between the vendor de facto standards that are out there and open standards, so we can move data fluidly back and forth. Being able to access and publish to the web. Like I said, rapid prototyping, automation, and scaling. Ultimately, also the ability to distribute very complex data sets, summarize them, and distribute them in a client-friendly way so a mobile device can view it. So yeah, we've got the format support, the web access, also supporting the wide range of geometries because you've got all these different data types that you have to deal with. Yeah, I think I mentioned some of these already. So what's the disaster management cycle look like? You know, it's a little bit arbitrary because all of these activities can be happening iteratively. But basically, before a disaster happens, to mitigate the impact of that, good planning is critical. And so if there are plans in place already and agreements between different agencies, that can certainly help mitigate things. And then there can be mitigation actions to sort of minimize the impact. And then in the response, I'll get into some examples of, you know, the more rapid you have situational awareness, the better. And I guess the idea in this slide is that integration is key through all of these steps. So whether that's FME or other tools that you're using to do data integration, each of those phases of the disaster cycle requires good data integration. So let's look at some examples quick and just keep an eye on the clock here. I'll try to whiz through this. One good place to start with is hazard mapping. So usually hazard mapping involves both, you've got to start off with a base map, and then you're looking at existing settlement patterns, existing infrastructure, and then what are the hazards are that you can intersect with that and figure out, okay, this is the critical infrastructure that if we lose this, you know, we're going to lose you know, the energy to support hospitals and other critical infrastructure. So basically that intersection between the hazard or the threat layers and your population and infrastructure. So that's really what hazard mapping is about. I've been with SAFE, I didn't really say, I guess I got the intro there. I've been with SAFE more than 12 years. One of the first projects I worked on was a FEMA DFIRM update. So it was the flood insurance mapping for FEMA. And so what they need to do, and clearly in the context of climate change, you know, if you're getting 100-year floods every 3 years, there's something wrong with your flood insurance map. So that's all been updated, and it's an iterative cycle where they continually update. They just look at what are the new weather patterns that are emerging, what are the trends, and how can they you know, look at that with a terrain model and figure out what the new flood extents should be. And there can be quite a bit of resistance to changing the flood insurance maps, the FEMA layers, because obviously that has a big impact on land value. If you weren't considered to be in the 100-year floodplain and now this year you are, now suddenly your insurance rates go through the roof. So there can be a lot of resistance, you know, economic or political resistance to having these realistic maps. There's some good example that we have linked to on some of our blogs on the Australian bushfires. So I was fortunate enough to go to be on world tour and see a really good demo of a tool that's used to mitigate this. So there's the Bushfire Attack Level rating, and these guys developed an app essentially to automate this. So they'll look at the back end in FME server in the cloud is crunching data on the topography, vegetation, and property boundaries. And the whole goal is to look at your property parcel and tell you, essentially give you a risk surface and say, well, here's your highest risk place to build and here's your low. One of the problems was typically people would want to build up on the hill where they have the nicest view, but that's also where the fire likes to go. So being able to come to a new parcel and instead of react to where the fire is coming from and try to, fight the fire, if they can position the building in the safest possible place, that helps mitigate that risk. So this was an award-winning app from the Alpine Shire Council, and you can read more about that online. Now, yesterday I was fortunate enough to sit in on a couple talks, and I came across this one from Mark Doring from Conterra. So I just threw in these slides today just because I thought this was really cool. So they have a new app that essentially analyzes all these different axes of risk. So everything from flood to earthquake, tsunami, wildfire, you name it, sort of all your worst case scenarios. And I think they get a lot of their data from some of the insurance companies. And it's actually, we looked at Vancouver, because I was sort of challenging, hey, you should put Vancouver on there and run the numbers. And you can see it's a fairly high resolution. I mean, I don't know, it would be meter level, but say down to 10, 20, 30 meters, you could see what the flood risk is or earthquake risk, that sort of thing. So if you were a multinational and you're looking where to situate your head office, you might be able to avoid some areas that have more risks than others. And then you get this detailed report. I think this is done, you don't have to go and buy the whole software package. It's just an app, and then you pay something like €6 per transaction, like per location that you want to check. So go to Conterra's website if you want to find out more about that risk analyzer. You can, before you buy a new property somewhere, you can maybe check out what the climate change risk is or something. Okay, so that's on the hazard analysis. So that's when you're planning. It's the more pre-planning you do, the better in terms of mitigating what the potential hazards might be. Now, what happens when there is an actual disaster? Now you're in response mode. How can you most rapidly assist the people that are in need? So one of the very first things that has to happen is to figure out what the extents are of the disaster. In many cases, this is not a 2D one-off snapshot problem. It's actually a 4D problem, because the disaster can be evolving in 3 dimensions. Let's say if it's a plume of smoke, a toxic smoke, or a plume of oil in the Gulf. And then it has a time factor, so it's spreading over time. And so being able to map that in 4 dimensions is critical. And when you're initially on scene, the logistics folks don't even know what scale of disaster you're dealing with until you can get some initial imagery back. So having a rapid assessment of that is really key. So one thing that I talked about yesterday, and you can always drop by our talk tomorrow for more detail, is we did some tests on UAVs of using those to do basically surveys. In our application, it's for marine search and rescue. So I won't get into too much detail because I talk about this on some of the other talks, but I just wanted to mention this more in conjunction with disaster assessment. So I was talking with a gentleman from, I think it's a Global Medic, and they are using UAVs to do rapid assessment in a disaster situation. And so a lot of the bottom point is key. It's very easy and inexpensive to deploy a UAV in a disaster zone, because you can just basically pop it up there and really quickly map it out. And so that's one resource that's kind of changing the capabilities that are there for early response. So this was a shot from Southern Coast. So they use UAVs for storm damage assessment, for example, if power lines go down. And this is the application for search and rescue. So I'll kind of flip through this. This is not, I'll differentiate, this is more emergency response testing than disaster. And the big difference there being, emergency is like you got to go to the ER. That's an emergency. Disaster is when the ER collapses. So it's a different scale entirely. But still, the ability to rapidly generate missions in this case that were flown by autopilot. So FME is used to generate the mission, and you can autonomously fly it and collect the data. So each of those waypoints, grab the data, mosaic it together. So the more rapidly you can do that, obviously, the quicker you could assess the damage. And there was a bridge collapse that they surveyed as well. So small scale disaster. And then they're using FME to push the information up on the cloud. And even though I said earlier that, well, you can't always bank on internet being there, that's more for the frontline responders. Often if you can get the data online, then there are a lot of people back home or on the web that can assist you in analyzing that data. So publishing to the web is still a very key capability to have, even if on scene you have very narrow bandwidth. So I came across this example, a Fort McMurray wildfire, and again there's a presentation that I think that was done at an Esri conference, so you can check that out for more info. So I don't have a lot of the details on this, but the idea here was the engineers are going house to house. So Fort McMurray, I guess this is just over a year ago, there was a huge wildfire. I mean, there were flames going right over the road. People had to essentially drive through the flames to get out of the town. There was a mass evacuation. It's probably the worst wildfire disaster in Canadian history that I know of. And so fortunately there was no loss of life except for, well, one or two people, flipping a car in the rush to get away, but no direct loss immediately from the fire itself. And so it was really quite an amazing effort to respond to that disaster. Now, following up with that, they had to look at, I think this particular, ATCO is a gas company, and so they had to look at where their outages were and map it all out. And so what they used FME Server for is essentially the engineers will go out in the field, check off each address and what the conditions were for that gas hookup, and then FME Server would essentially suck all that information in, spatialize it, put it into geodatabase, and make it available on ArcGIS Online. So you can check that out for more info. So I mentioned that key to each of these stages is data integration. I'm just scratching the surface here, but obviously FME is very good at this. So being able to connect, reproject everything to a common frame of reference, because sometimes you get data, let's say those spreadsheets are just X and Y's, they don't even have a spatial reference, and so you may have to have a local coordinate system for that. So bringing everything together in a common frame of reference, being able to interpret the data, and then often you'll have to do data model transformations. So if you have different classes, let's say flood level here, and different units, meters, feet, you have to convert everything into a common interpretation. And then there's usually some kind of validation and synthesis process. I'll just briefly mention EU Inspire. So one of the reasons why Inspire was envisioned in the first place for the EU is primarily, initially from the environment, and we heard from Jan this morning. There's some excellent summary there what the European Environment Agency is doing. So it's from an environmental management perspective, but another key aspect is disaster response. So they've had, for example, spills. There's been a mining tailing overflow, for example, in Romania. It was I think an Australian mining company. And so you got this toxic overflow, and then it gets into the Danube River. Now you suddenly have 4 countries involved. And so now you're trying to coordinate a spill response, and you have data that crosses 4 international borders. So if you don't have this work done ahead of time where you can map it all in a common schema and a common frame of reference, now you're going to spend the first couple of days just cobbling data together. So one of the key aspects of Inspire is to provide all of these themes as just part of your base map, and then it makes response a lot easier. So this covers everything from base map administrative areas to hydrography, elevation, and then the risk zones themselves for things like flood and fire. Yeah. So again, following some of those principles I mentioned earlier about being based on common standards for that community and open standards, OGC standards in terms from a geospatial perspective, and then open standards for those web services that are listed. All right. Now next on to notifications. So that's something that from an FME side we've invested a lot in for FME servers, support for notifications. And I'll just look at a few quick examples here. So on Tuesday we had workshops, and so Stuart and I kind of, admittedly we sort of cooked up this flood notification thing, but then when I went to research what would be a good schema for our notification message, I actually found some real examples, so I'll tie that in a sec. So the whole idea from this flood scenario, and there's a knowledge base article, so if you just search for flood notification scenario, FME UC, you'll find it. And there's a whole complete example you can download and play with it. So the idea here is it's all based on web services, both consuming and then ultimately publishing. And so what you're doing is, first of all, you interact with an API for a customer database. And the idea here is that customers register with this service so that they can get flood notifications if, let's say, there's going to be coastal inundation or tsunami or what have you. So they'll register with that service, and then if they're in a flood risk situation, they get an email, or actually in this case it's a phone call through Twilio. And so the first step is in the FME workflow is we retrieve the customer data. We generate flood polygon based on a real-time water level feed that we have from, in this case, from NOAA. Then we determine, based on an intersection of the DEM and that flood level, we determine who's affected by the flood, and then basically we clip out the customers that are affected or point on area, and then send notifications through Twilio. So I don't have time to get into the details of what's going on in the workspace, but you can download that from the knowledge base article. So this is the web service. This is not EU Environment Agency. This is the UK Environment Agency. And I kind of stumbled across this. So they have a web service. There's another article on the knowledge base from our new JSON tutorial. So I put a plug in for that. And this is kind of a cool one because what happens is you put in a query and it gives you a list. I'll just highlight this really quickly. So the top query under number 1, this is sort of part of our web services workshop. So this gives you a list of all severity level 4 floods, and then the message back is just a list of flood names and IDs. It actually doesn't give you the geometry. So then you have to use FME to parse out the flood polygons, and then you get the GeoJSON of the actual flood extents. And then when Petra and I were working on this, we built the whole demo, and then the next day it didn't work, and we were like, oh, bummed out. We put all this effort in, and we're not getting any polygons. And then we actually went back and tested it in the browser and realized that actually that day there were no floods. So what was a disaster for us was, better situation for everyone else. Yeah, so that's the workspace. So. And there's a number of other examples of this. I'll try to skip through this stuff pretty quick because I've got more slides than I have time to cover. But so there's another FME notification service that's been used for generating real-time earthquake reports. So Stephanie from the California Earthquake Authority using FME server to generate earthquake notifications. So there's a blog on that. You can check it out. So now after the response, we're getting into sort of the recovery, rebuilding phase. And so how can FME be used for that? And with there's sort of two aspects of that. There's the immediate response, there's the reconstruction, and then something I think that is sometimes neglected is this whole discussion of how resilient. So after a disaster, how can things be designed or implemented or restored in a way to make things more resilient so that you're not as exposed to a future possible disaster. So I was down for the FME World Tour in 2013, so 2 years after the 2011 Christchurch earthquake. And so that, I was able to, that was basically the first time we had the World Tour in Christchurch, so Locust was hosting it. And so I had a great opportunity to meet the folks from LINZ, Land Information New Zealand, and SCIRT, which is the group responsible for rebuilding Christchurch. So they actually, what was a real disaster with serious human costs and financial costs was, on the flip side, was a great opportunity for, they had to rebuild. They could rebuild both the physical city and also their IT infrastructure. They had some pretty big budgets to work with in setting up an SDI. So there's what it looked like, and this is like, I guess, almost 2 years after, and you can see there's still vast parts of downtown that are not rebuilt yet. And there you go, there's the reconstruction. So that that whole church, most of it's, I guess they lost about a quarter or a third of it. And so you can see it's a bit of a tricky process to rebuild. And that's where we had the World Tour event. So my last main point here is on scenario analysis. And this is kind of open-ended. There's lots of room for new development here. The one area where I have a bit of experience is on NetCDF. So this is something that I've worked on with OGC Testbeds. I've been participating in some of those. And NetCDF is essentially a data cube, a multi-dimensional raster where you can have any number of bands. Typically, one band, you might be dealing with X, Y, and T. So the third band might be time. And so often what will happen is you will have a climate model or a weather model. That's your first level of simulation or forecasting. That will generate a flood model, and then you can use that to load impact and cost models. So you have a number of interconnected models. So with the test bed, there's a lot of agencies involved there, a lot of US federal, things like FEMA and NGA and Homeland Security, and a number of different agencies there, NGIA. Yeah, and LINS was involved in that one as well. So just some example of some of what's involved in the scenario. This particular scenario for testbed 11 that I worked on, they kind of came up with this worst case scenario for San Francisco Bay. So what would happen if you had you've got sea level rise in terms of climate change over time, and then on top of that you have high tide and then a storm. So you've got a cumulative effect. And so modeling that effect and then the impacts of it. I won't get into all the detail, but using FME, NetCDF is a bit of a cryptic format. Not a lot of tools can understand it. So being able to read that from the models and then essentially chop it up into geotiffs and then write it out to KML. And that's what this workspace does. So it breaks Don's 10 transformer rule, but it's not too bad. And then you can kind of see, I'll just let it run here for a sec. So let's fly down to SFO. So that's actually not just San Francisco Bay, but San Francisco Airport. And then we just got to set up the time slider. So basically, I just chop up the NetCDF and then set it to time, and then you can just hit play here. And then you can kind of see, hang on a second, I got to make the time window wider. So this is not, I did a simulation like this for Vancouver ages ago, but I cheated because when I first did this, I just pushed a polygon below the surface of Google Earth's DEM and then slowly raised it. But that was cheating. This is actually this is a high resolution flood model where the rasters are actually computed based on a very detailed terrain model. And then that's over time. And this is, there's a term called downsampling. So when you combine a global model with a high-res local model, you can use a global model to essentially help calibrate the local effect. So let me just stop that. So just about done here. All right. Okay, so we exposed that. 52 North set up a WPS to expose that. So just a little nod to some of the other talks. I mentioned Contera's GeoRisk Analyzer. There was a talk yesterday afternoon by Lauren from Missouri on the 911 system, and there was also a very cool talk on wildfire notifications. So check that out. And here's some other examples I didn't have time or didn't have to include. So routing by London Fire Brigade. See, these are all using FME. TNRIS, so Texas Natural Resources, and Colorado Emergency Management. That's data sharing between the state and local government level, two-way data exchange. So here are some of my recommendations going forward. Definitely have a plan, avoid single points of failure, establish roles and responsibility and relationships ahead of time. And this is my last one here. Run realistic simulations. I think that's just sort of a plug that you really, that what helps you suss out where are the problems and the bottlenecks. So just to summarize, Rapid generation of the disaster picture early on is key. I think FME has something to contribute at all aspects of the disaster management. We've got good support for standards, but it's important that you have flexibility so you can bring in new ad hoc data sources. Web service support is critical in the sense of real-time data, but you have to also be able to work offline. And expertise is always at a premium, so automation is always good. So that's it. Do we have time for questions, or are we out? One or two questions, and these are just some questions to think about. You know, where are you using FME to support disaster response, or what can we do better? Because maybe there's tools that we can add to FME to make it easier to support.